very good afternoon to each and every one of you. Sidang hadirin yang dihormati sekalian, and also our viewers on online platform. Sesi petang ini akan dimulakan dengan forum interaktif dengan topik yang cukup interesting, how the technology can overcome the new normal. Dengan ini majlis mempersilakan moderator forum iaitu yang berusaha teknologis Dr. Eeydzah binti Aminudin. She is the senior lecturer of Fakulti of Civil Engineering, Universiti Teknologi, Malaysia. Dengan segala hormatnya dipersilakan. Over to you, Doktor. Berikan tepukan hadirin sekalian. Terima kasih.
Okay, thank you so much, Point Moderator. Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon. So before we start, I would like to invite our three panels to be on stage. Please welcome. Thank you. So before we start, did you guys have a good lunch today? Okay, so I do hope today's more on sharing discussion, able to open up the idea on how we going to focus more on expediting, our construction technology. So with this, I would like to thank CIDB for having us today, and also I would like to give a very thankful to CIDB, the Honorable Pengarah Negeri, and to distinguished guests, ladies and gentlemen. So a very good morning, good afternoon. First of all, I would like to thank, again, CIDB for inviting, and I think CIDB already set a magnificent flow of this special occasion of Jelajah Pendigitalan Pembinaan 4.O di Sarawak, ZON Sarawak. So we would like to thank again, and thank you for holding on. So before we start, allow me to chair this session. I believe we can able to talk in both languages. So we do have Bahasa and also English. Perhaps since we are also in Sarawak, so I think the panel also able to convey in Sarawak dialect. Okay, so you are most welcome. So before we start, I would like to introduce myself. Again, I'm Eeydzah Aminudin, the senior lecturer in UTM, and your moderator for this afternoon session. So we would like to allow me to introduce our respective panel for today. We have a line of experts, I think, from various background and discipline. We do have from government background, manufacturer, and also the distributor. So we would like to go into the introduction of our first speaker. So we do have Engineer TS, So we do have engineer technologist Muhammad Faiz Shapiai. So he is actually the senior civil engineer, BIM unit, integrated asset planning, JKR Malaysia. So our first speaker, Engineer Faiz, obtained a Bachelor of Civil Engineering and Masters of Project Management from UTM back in 2015. He is also a professional engineer of Board of Engineers Malaysia, 16 years serving in JKR, including 9 years of experience as BIM expert in unit BIM, implemented various BIM pilot projects, facilitate project teams in BIM projects, produce BIM software template, doing R&D, and lots of BIM application, establish collaboration with university, part of it is UTM, and we, Engineer Faiz have tremendous transformation effort, especially in promoting BEAM application as the success in Malaysia. So we also have our next speaker, next panel. Okay, so our next speaker is Engineer Ivonson Kwee, okay, the Senior Business Development Manager. He oversees Engineer Ivonson obtained a Bachelor of Civil Engineering from Universiti Pertanian Malaysia, and he's also the professional engineer and certified IBS trainer for Academic Binaan Malaysia, Sarawak, having a vast experience, more than 30 years experience, including overseas design department and factory operation, involved in business development of new product, planning, management and execution of site installation of IBS, manage and organize design team, and also have a very various project involved, part of it like Maidin Shopping Complex, Viva Shopping Mall, Giant Samariang, and also the Unimas Medical Faculty. All right, and our last panel. Okay, so our last panel is Engineer Pramod Kumar, Karunakaran. All right, so Engineer Pramod is our Executive Vice President, Project Delivery, Sarawak Energy. And Engineer Pramod is actually obtaining the Bachelor of Science in Communication, Electronics Engineering from Leeds Beckett University, UK. Also having a certificate in International Management from INSEAD, France. And holding the professional engineer focusing in certification of instrumentation and control from Board of Engineers. So holding a vast experience, including business leadership and head of project directories, with demonstrate leadership accomplished in both areas of operation and project deliveries in oil, gas, petrochemicals, and power, successfully lead operation and implementation, as well as excellent transformation effort in record operating and project delivery performance. Drove corporate center, technical capability building, served as CEO of 2 multinational joint venture corporation, as president of Malaysian Gas Association from 2012 to 2016. So I think he has also served business head for gas and transforming capability building, negotiation in area of oil and gas. So please welcome our 3, I can say, very good experts. So again, give them one round of applause. So this moderating session will be conducted this way. We're going to have the presentation, 50 minutes from all panels, and follow up with question and answer. And towards the end of our session, we're going to do the open discussion. So without further ado, I would like to call upon our first panel, Engineer Technologist Muhammad Faiz Shapiai, to present, to share up before we go on actually understanding of how the technology can overcome the new normal. So let us look into what is actually been done by JKR. Please welcome.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon. Okay, first of all, thank you to the moderator, technologist Dr. Eeydzah, and panelists, okay, Engineer Ivonson and Engineer Pramod. Okay, so nice to meet you all. Alright, so saya memaklumkanlah kedatangan semua peserta lah, sama ada secara fizikal dan juga secara online atas talian yang sudi bersama kita sehingga ke petang ini untuk mendengar interaktif forum. Okay, insyaAllah I will try to explain how Building Information Modeling or BIM, okay, that we implement in Jabatan Kerja Raya Malaysia. Alright. So the first thing, actually JKR is start with BIM on 2007. Okay, our Director General, okay, introduced BIM on that time, and we try to get what is the suitable software that we want to use in JKR. Okay, so that we decide to use Autodesk. Alright, and then we have some pilot projects that we move on until 2015. That is around 9 projects. We call it as our pilot project lah. We try to manage to implement BIM in our projects untuk konvensional dalaman, konvensional perunding dan juga reka dan bina lah. So we have a lot, we have lesson learned in that projects, and from there we come out with our first BIM guideline and BIM standard, okay, at JKR, that we already use to all of our projects in JKR, okay. And then the next one is we call it as a phase 2. The phase 1 is actually is our awareness and readiness, how we want to implement BIM in JKR projects. Okay, so for the phase 2 is we focus on development, okay, development and implementation in terms of the process, okay, and then in terms of our people and technology. Alright, so we managed to come out with we publish our work process in BIM, and then we develop our competency development for our staff in JKR. And then also we put our KPI, alright, in our JKR strategic plan 2016 and until 2020, that we target to achieve 10% for project that worth 50 million and above, okay, for building projects. So we targeted and we already achieved 20% for that KPI, alright. So we see that the BIM can be done, okay. So actually that the BIM can be done if the government push the industry actually, okay. So by 2020 we come up with our policy in BIM, and we have our Surat Arahan KPKR bilangan 18/2020 lah, that we want to implement BIM in all our JKR projects that is worth 10 million and above. Alright, okay. So then we have around 30 projects that we implement in BIM. So that one in RMK 11 lah. So all the projects, almost of the project is from the Kementerian Kesihatan Malaysia. So why the Kementerian Kesihatan Malaysia wants to use BIM? Because they see that the BIM model can help them to continue into the pengurusan asset and facility lah. That's why they want the BIM model, and then they can have the SPID model and the data for asset information that can be used into the asset and facility management. Alright. Okay, for the phase 3, so 2021 until 2025. Okay, we want to move in, we try to implement BIM, and we want to expand the BIM use into GIS, prefab and modular coordination such as PPVC, IBS, okay, and then facility management, okay, and then sustainability, so that we see that we start from the BIM, we can move to other technology that can be used during all the whole life cycle in our projects. Okay, so we until now we have around 85 projects RNK 12, and there will be more projects that will be used BIM in our project. So for 2021 until 2025, okay, we targeted 50%, okay, 50% project that worth 10 million and above, using BIM, okay, for all the project JKRs. And every year we will increment into 10% each year. So that by 2026, all of our projects that worth 10 million and above, okay, JKR will use fully BIM, okay. So that's our journey. So from non-BIM to BIM. So it is a long journey that we took, and we try to consider with our industry player, okay. Sebab kita tahulah industry also have their hurdles to implement BIM, okay, in terms of in their organizations or in the projects, okay. Okay, so this is our vision and mission BIM in JKR, that we want to transform industry revolution 4.0. So we want to go for the 2026 until 2023. We like to have our pelan pendigitalan pengurusan aset menyeluruh. So total asset management. So that total asset management, okay, we try to bring the technologies such as BIM, okay, and then FM and so on into our pengurusan aset project and pengurusan aset juga, okay. So actually, when we talk about BIM, it is a process, okay. So my friends in the morning, Technology Zanira also mentioned, okay, what is BIM actually, okay, and then another our colleagues, okay, already mentioned what is BIM. So actually, BIM is a process that we build, okay, we build from the planning, design concept, detail design, okay, into 3D model that have an information inside the model. So we use it for the 3D, 4D, 5D, and so on. And also we try to incorporate with IBS and augmented reality and so on. So we need, if we talk about BIM, we need to have a sharing platform. So in JKR we have JCloud. We call it as a JCloud to share all the data, all the models, okay, to the designers, consultants, and contractors, okay, so that they can share in one platform, in one source, all right. So they can coordinate, they can collaborate each other by using this platform. Okay, so after that, all this model, we handing over it to our clients. Okay, so the clients can get the BIM models into our e-coms. We have another platform that put all our repository data. Okay, that one we have all the SB model, SB data that can get the client can get all the data from there. Okay, so actually BIM can give the added value in terms of pengurusan asset facility, value engineering, okay, sustainability, and emerging technologies and GIS. Actually, BIM can accelerate, okay, the adaptation of technology 4.0 because it can improve the work process, it can increase the productivity, and also that can use for sustainability analysis, sustainability, amalan hijau lah, alright. So JKR from 2020, as I mentioned, okay, we have come up with our policy. So actually JKR is a pioneer to adapt BIM in Malaysia, so that all the industry player can support us if they are doing our projects in BIM. Okay, that's why we come up with our initiative. We put, even though we have Surat Arahan KPKR, we also put our JKR strategic plan. So we target, okay, not implement 100%. We slowly move 50%, 60%, 70%, okay, and so on, so that the industry player can catch up, okay, how JKR implement BIM in the projects. Okay, so until now we have around more than 120 projects that implement BIM. So okay, we know that when we use BIM, it can helps a lot, okay, in terms of reduce clash, okay, increase collaboration between among parties, okay, increase the communications among parties, and give a best decisions, okay, actually for especially for the client and the designers to come out with the design, okay. And then when we talk about BIM, there are three focus area that we are focused. The first one is a process, okay. We need to develop the work process, the BIM reference documents, so that it can be reference to the contractors, consultant, and others. Okay, and the second one is technology. All right, actually the technology is another part that important that we need to upgrade. Okay, we need to upgrade. We need to invest. Okay, to make sure that when we talk about BIM, we need to invest to change the way how we work by using the BIM software. Okay, that is some example. And then also the ICT also we need to upgrade. Okay, so that when we want to share between each others, okay, all the data, all the models, it can be smooth. In our work process. Okay, and the last one is people. People actually we need to develop the competency. Okay, so in JKR we managed to develop our own our competency and not forget to the contractors, to the consultant that use BIM. We will try to help them by implement the BIM engagement in the projects. Okay. So this is example the work process in BIM. Okay, from the planning, okay, the design stage, the procurement and construction until handing over, and then the BIM models we will pass to the team asset team. So actually when we talk about the BIM, it is all about the process, and you need to know what is software is suitable during the phase that we want to implement, and then we need to know the BIM users, the objective of BIM, the benefit of BIMs. Okay. So after that, okay, we need to make sure that when we want to adapt BIM, okay, adapt BIM, the environments, okay, the environment we need to change. Okay, before this we are using only 2D drawings. Okay, but when we talk about BIM, we need to change how the way we work. Okay, we need to have a laptop, okay, the projector or television, so that we can coordinate each other and communicate each other, so that we can improve the way we talk, the way we discuss, okay, among the clients, designers, and the contractors. Okay. So actually, the design, we build the model, okay, and then the consultant will discuss each other's. And also when we in constructions, we bring the models into our tab. Okay, we can validate the construction, and then also for the clients, they can see 3D visualizations, so that they can comment it. Okay, and then the designer can improve the design from the client perspective. Okay, so this is another example how we want to share the model. Okay, so when we talk about process, the BIM users, also we need to have some work process to share, how we want to share with each others. So that's why when we talk about BIM, it's just not only the model, but it's process in terms of the way we develop the model, in terms of we share the models, and in terms of we want to share the data. Okay. So in our industry scenario, okay, so this one I took from the Kerajaan Abah lah, 2018, okay, industri 4.0 ubah cara kerja hidup. So sebenarnya kita pun perlu ubah cara, okay. Sebab itulah kalau kita tengok, kita willing to invest smartphone even though it's expensive, okay, to use in our life, because we know that the way of our life will become more productive, okay. So that's why kalau kita tengok memang government also kita try to push, okay, the industry, okay, to use the technology so that we can move forwards to the industry 4.0. So ini semua adalah contoh-contoh Kerajaan Abah lah from the 2016 until now, okay, that talk about BIM, alright. So by 2020, 2021, okay, the government also try to governance initiate the BIM in all the projects, especially for JKR projects. Okay, what about the world? So actually all around the world already implement BIM. Kalau kita tengok negara-negara maju, negara-negara membangun is already implement BIM. Okay, especially our neighbor such as Singapore, they already implement BIM to 2012 if I'm not mistaken. And then right now like Indonesia, Vietnam, okay. Actually we are the second one that implement BIM, okay, in Asia Tenggara lah. But now Indonesia and Vietnam, they are lagi majulah daripada kita sebenarnya dari segi penggunaan BIM. So actually kita take a long time to use BIM, to use the technology in our construction industry. So even though we are one of the industry that start early, but right now I think we are dah terbelakang lah from other countries such as Indonesia and Vietnam, okay. So kalau kita tengok CIDB actually have come out with the report 2016, the adoption rate of BIM actually is really low lah, okay. So I don't know for now is it increase or still maintain at the same level, okay. So JKR 2013 we have industry engagement, okay. On that industry engagement we try to ask if JKR use fully BIM by 2016. So and on that time all the industry are not ready yet. So that's why we try to not to fully implement BIM on 2016, okay, but we try to put a KPI lah, okay. That's why on 2016 tu kita hanya target 10% sahaja, okay. Sorry, itulah 10% saja projek yang bernilai 50 juta, okay, bukan semualah. Sebab kita nak tengok macam mana cara industri bergerak, okay. But kalau kita tak bergerak sekarang, okay, by 2021 dia akan jadi masalah lah teknologi kita sebenarnya. Jadi that's why kita push, okay, to increase our KPI 2021 tu kita pergi kepada 50% projek ni 10 juta pula. Tadi 10% 50 juta, sekarang 50% 10 juta. Jadi nampak actually government very serious lah sebenarnya dalam penggunaan teknologi ni, sebab kita tahu dalam RNK 12 Dasar Pembinaan Negara 2030, Construction 4.0, Pelan Strategi Organisasi, Pelan Strategi already mentioned to adapt technology. Okay, one of them is building information modeling. So we know that if we use the BIM in our project, it actually can increase the productivity. Okay, sebagai contoh lah. Okay, contohnya arkitek. Okay, one of our arkitek, konsultan arkitek, before this when they are not using AutoCAD. Okay, actually BIM ni dia ubah cara je from 2D to 3D. Before this, one of our architect using AutoCAD. Okay, when they want to do submission, it takes a month for one project. But they change the way they work by using BIM. Okay, by using some certain of software, they manage 2 or 3 projects in 1 month. Okay, so that's why actually technology can help us, but how we want to use it, the way we want to use it, and then we need to have discipline to use technology in our works. So this is the Kementerian Kerja Raya said to use teknologi lah in Dasar Pembinaan Negara 2030. Okay. So Industry 4.0, emerging technologies, or R 4.0, and then actually BIM can integrate the process, especially for the prefab and modular coordination into systematic and efficiency lah. Alright, so that kita nampak lah dengan menggunakan BIM ni dia boleh bantu percepatkan kita punya penggunaan BIM dalam VR, AR dan sebagainya. Dan juga kita juga nampak dengan menggunakan BIM ni, kalau kita kita reka bentuk secara modular sistem modular, ia juga banyak bantulah untuk kita proses penghasilan bermula daripada reka bentuk sampailah kepada pembinaan sebenarnya. Okey, dan juga penghasilan lukisan in term of we generate the drawings, okay, especially for the SPIT drawings, it comes from the models, okay, so that model tu macam mana model dibuat, macam itulah dia akan keluar. So tak ada, kita bukan sebut from 2D to 3D. Actually we talk about 3D to 2D lah. Maksudnya when we want to come out with the drawings, okay, it generates from the model, so that the contractor can generate model, and then the client can get the accurate, okay, SPIT drawings, so they can use to others work lah, such as untuk pengurusan aset dan facility. And then actually when we talk about BIM, the design model that consultant develop, okay, it is saya cakap serupa lah, okay, dengan apa yang kita bina. Okay, rather than before this when we talk about 2D model yang dibuat tu nampak masa planning tunjuk macam ni contohlah guna lukisan biasa, SketchUp ke apa ke, macam ni. Bila redesign macam ni, bila pembinaan macam ni, tak sama. Okay, tapi bila kita guna BIM memang plan macam tu sehinggalah kepada pembinaan, kepada serahan. InsyaAllah sama, kecuali dia punya color lah, kita punya cat lah. Okay, cat tu tengoklah depend pada klien lah. So maksudnya in term of ruang, okay, in term of the space, in term of the height, that will exactly same as per design model. Okay, and then actually BIM, if you develop BIM models, okay, we put all the information for the kecekapan tenaga. Actually we can help them to analysis tahap kecekapan tenaga lah. Okay, so that macam contoh di Malaysia kita menggunakan MyCREST ataupun JKR kita dengan PH JKR. So sebenarnya ke dalam tu point kita boleh dapat satu point untuk bila kita gunakan BIM, okay, we can get a point, okay, additional point for using BIM in sustainability analysis. Okay, other than that, okay, kalau kita tengok actually this is the absolute why JKR, why government use BIM, okay, in our project. Actually we want to help to register all the immovable asset, the asset lah, sebab kita nakkan asset semua berekod secara digital. Okay, not dulu manual, sekarang kita tak ada lah. That's why kita nakkan the final ultimate actually by using BIM is we want to have the asset information so that our clients can manage all the assets during the asset and operation and maintenance phase. Okay. Okay, in terms of construction, do I have 2 minutes more? Okay. In terms of construction, actually, contractor can visualize, combine with the 4D, combine with the work program and the 3D model, so they can get activity, sequencing activity during the project lah. Okay, and then we can generate the quantities also. Okay, so this is some example lah. So the way how we work, how we want to present. The first one, the video, the first one, we are using Google Meet to discuss with our clients. Okay, during pandemic. Okay, so actually we have the models, we can discuss, okay, among us. And the second one is the 4D and 5D. We can look the sequence of the projects, and the third video we discuss, okay, between the SO, contractors, consultant, okay, during the construction stage. And then the fourth of the video kita gunakan untuk VR lah. VR, AR, sebenarnya kita boleh buat lah. So klien dia nampak dengan lebih jelas sebenarnya. And then we can use, upload into our tab, we can validate or we can use for put the RFI, so that kita boleh dapat ni lah, information, okay, during the construction stage. So this is how we want to change the way we work in JKR, our designers, consultant and contractors. Okay, we want to move to level 2. Right now we are in level 2 actually. So if we want to level 3, we need to have a seamless process, and all of us need to use the technology. Okay, so barulah kita boleh pada level 3. Okay, so that's I hope that from my presentation, okay, it can give you all some glimpse by adapt technology, by using BIM in the projects, so that we can increase the productivity in our industry, construction industry. So there are 3 main things. We need to go into total asset management, digital work process, and big data analytics. Okay, so that's from me. Thank you.
Right, thank you so much, Engineer Faiz, for very insightful information. Maybe I think industry would like to know what actually JKR Unit BIM can serve them. I mean, looking into the whole initiative, how actually JKR can help industry perhaps, because you do have lots of projects, lot of involvement. So maybe you can share a bit, sir?
Initiative. Okay, in terms of initiative, actually in our plan strategy JKR 2021-2025, one of our initiative is implement BIM. Okay, 50% that project worth 10 million and above. So that is the first one. So that when the contractor consultant do the project for JKR, they need to use BIM. Okay, so that is the first initiative. And then we also have another one. Okay, actually we when the contractors or consultant using BIM in our project, we will do some engagement for the consultant contractor, so that they know what is the requirements that JKR wants. Okay, so maksudnya kita tak adalah when we talk about BIM, perunding dengan kontraktor buat macam je nak. Okay, we will have some engagement. Kita akan bagi tahulah macam ni JKR nak. Okay, how you want to develop the models. Okay, this is the requirement that they need to follow. And then another thing, we also give, okay, when the contractor or consultant using BIM for JKR projects, we will give you a template, okay, template and our standard. so that you can comply using our standard lah. Sebab itulah bila buat projek JKR, kita akan bagi template JKR tu dah fully comprehensive lah. Dalam tu in term of naming convention, the code, the code, the family, kita dah ada dalam tu, kita dah ready kan for the consultant or contractor. But they need to know how to use it. So how to use it, we have our another document that consultant contractor can follow lah. That one pun kita bagi free je lah sebenarnya. Dokumen tu kita bagi free. Garis pandang piawaian, you can download it from our website, and then when talk about how we want to use our template, we will give you another document. How to use it. So that is some initiative lah. That JKR try to help the contractor and consultants. In term of incentive, tak adalah yang tu sebenarnya. Cuma kita masih lagi lah, kalau buat projek, kita try to include some cost into our contract. Maksudnya tak adalah kita tak ada langsung, ada. Sebab kita dah consider all of that into our project. But when you talk about is there any additional cost, for me, no lah. Sebab the benefit tu you can get back. Let's say for the contractor does not develop the model, the consultant yang buat model. Contractor will get the model, bukan buat dia akan dapat model. So contractor tu lagi mudah nak update model, nak keluarkan lukisan sebab you dapat model. Before this you tak dapat apa-apa, you kena buat sendiri, betul tak? Keluarkan lukisan. Tapi bila kita buat BIM ni sebenarnya memang ada, kita dah bagilah. And then kita tengok in term of cost for you develop as-built drawings, the cost actually it is same lah, sebab you dapat model tu and then you boleh come up with the as-built drawing. So that one kita nampak tak ada masalah lah dari segi pengemas-kinian ataupun pembangunan model lah oleh kontraktor. In term of consultant pun sebenarnya the way kita change the way we work lah. So all the front load, all the back load kita bawa ke front load sebenarnya, and then kita boleh resolve all the clashes pada peringkat awal. So actually it helps a lot to the consultants. Alright, thank you.
Alright, thank you so much, Engineer Faiz. So far, I think looking into how JKR, CIDB implemented the whole BIM process is very unique, because I've been attached in JKR last year for 1 year, and I can see that lots of knowledge other than, the whole initiative of JKR doing the template and how CIDB come up with the library, it opened lots of other so-called opportunity for us to venture and look into what's next for our whole organization. Thank you so much, Engineer Faiz. So next, we will call upon Engineer Ivonson. But before that, the whole members of the floor, if you do have questions, please hold on first until the end of the session, because at the end we're going to open for discussion. And meantime, for our virtual participant, you also can drop us any question. So our team going to tap in questions, and we're going to open up the question at the end of the session. So next, we're going to look into 3D printing. I'm sure that everybody wanted to know more how 3D printing can be, I can say, a success for Sarawak for our company next, Sarawak Consolidate Industry Berhad. So I would like to know more, because looking into 3D concrete, of course we need to have a very fast hardened concrete. So how the initiative is being expedited. So I would like to call upon our next panel, Engineer Ivonson Kwee, for sharing the session. Please welcome.
Yeah. Okay. Hello, testing. Okay, yeah, thank you, Chairman. And can you hear me? Okay, all right. First of all, good afternoon to everybody. I hope you're not asleep. Normally, afternoon is always a very challenging time to listen to talks, especially when you're seated since morning until now. Likewise, anyway, I try to make the presentation as interesting as possible, and do jot down your question whenever you have, so that later on you don't forget to ask, because I'm sure there are plenty of questions that can be addressed from the floor. Okay, first of all, my topic is 3D printing in construction growth, benefit and the challenges faced. And okay, these are the outline of my talk, a very brief one, introduction, and then and we'll end with some very interesting video presentation. This is our SCIB on video presentation of how we do the 3D printing. And for your information, it is already here in Sarawak, Kuching. It will be launched by the Minister of Work next Tuesday. And the member of the public will be able to see the completed 3D printing house. Okay, introduction. Let me introduce you to our company. We are Sarawak Consolidated Berhad, Industry Berhad, and we founded in 1975, so it's a very long time. And we involve in all kinds of projects, from small enterprise into a very reputable group of companies until we are listed into the main Bursa Malaysia. And we are a company that likes to offer our client solution to our construction industry, because as time goes by, there are many challenges, especially recently when we have been through pandemic. So it's a huge challenge for all our construction industry, especially contractors in Malaysia. So currently, SCIB, we have 3 factories, all situated in Kuching, and we also expanding our subsidiary in KL, in Cyberjaya office. So we are actually expanding our facilities, and hopefully we can expand to our neighboring countries, especially our neighboring Kalimantan. So we are looking at expanding bigger and bigger as a corporation in Sarawak and Malaysia as a whole. So what is construction 3D printing? It's actually a computer control, and is designed like normal, using AutoCADs. But the only thing is that like BIM, similar to BIM, where we design, instead of design 2D plan, we design straight 3D building. That means we have XYZ coordinate. And those of you who are familiar with AutoCAD 3D modeling, so you design the whole structure building in 3D, and then you export it into software. So in construction industry, 3D printing can be used to create so many types of structures. Is unlimited. Whatever that you can think of the shape, especially architects, they are very innovative, and they are interesting ideas, because being so many years as engineers dealing with architects, they have so many crazy ideas that we engineers have to suit them. So now we have a solution. Even as a contractors, we can suit to the needs of architects, especially because architects, they would like to have beautiful structures, not a dull structure. So 3D printing is one way where we can help to make that realize, to be a reality. And at the same time, as a contractors or even as a developers of machine, we also look into costs. So cost is always go hand in hand with the design. So that's why I always say, are we ready? Before we come to the conclusion to buy this machine, we do quite a bit of research before pandemic. Actually, right before pandemic, I still remember where we went to China, 2019, to look at the 3D machine. At first, we go to the China, then we go to Europe. We compare to the 3D printing machine. There's so many criteria, even when we decide to use 3D printing in Malaysia. We run through all the risks, all the challenges that we can think of, because nobody, even ourselves, have experience. So we can only imagine and do some research. And we go and visit companies who produce this machine, and of course, we hear from them. Of course, we hear all the good things. But then we try to research what are the limitations as far as our Malaysian climate construction is concerned. So are we ready for 3D printing in 2022? So we started to look at the machine, and we started to buy in 2021. And from there, we do our own research on so many things. So later on, I will share with you in detail briefly. So the innovation in 3D technology is actually, it's like our own printing that you use every day in your office, in your schools, 3D printing. And I know architect, you have 3D printer. We call it 3D printer, small one, not the big one. So in construction, we are talking about 3D printing of big scale. So normally, like architects, when they do design print, they do their design is 1 to 10 scale or 1 to 100. But for us, contractors or even developers or builders, when we build using 3D printing, we are building 1 to 1 scale. Meaning to say we are building the actual size of the building and not using pen or ink, but using concrete. So that's what we call 3D printing in construction industry. So the machine that we bought, finally, we decided to choose the cobalt machine, 3D printing machine from Denmark. Actually, sorry, can't see my eyes. Okay, maybe can I stand? I better, yeah, better. This 3D printing is actually, they started in Europe, and one of the pioneers is found in Copenhagen, Denmark. It's a very nice country. And they founded the company in 2017. And this Cobalt is a globally leading company who champion 3D printing technologies. And it is funded by the government of Denmark. So from there, they started with 35 3D construction using the first model, that is BOD1. And upon that construction, they've researched and done many tweaks in improving the machine. And that's where they come up with this second generation of machine, which we call BOD2. So BOD2 is where we SCIB, Consolidated Industry, decided to purchase one to do our own 3D printing here in Malaysia. So it's a newly upgraded and much improved from the earlier version of BOD1. Okay, so if you can see in the slide there, these two photos, actually 3D printing is very simple structure, but the technologies is on the software itself and also the materials. Okay, so the specification of the machine that we bought actually is suited to build a double-story detached house. At least the width of the house, maximum width is 14.6 meter. That means we have a printing that can print any structures with a 14.6 meter wide, and the length can be as long as you like. That means you can print a terrace house, 10 unit, or I think maximum is how many units? Architects, one terrace, I think 12, right? 12 is the standard, the local authority. So the maximum printing width, 14.6, you can print one semi-D or even two semi-D link. Okay? And the maximum printing height is 8.1 meter. That means we can go up to 2-story maximum. In future, maybe they will be even going up to 4 to 6 story. But for the time being, is 2-story maximum. Okay, and the printing speed is about 1 meter per second. So imagine you can print a concrete structure in 1 meter a second. Okay, so the layer of the height of the material is actually a module. It can be adjusted depend on the design and also the design mix. So that one I won't go in so much detail. But most important thing is that the software that we use actually is a slicer software. So this is the technology that we learn when we operate the 3D printing machine. Okay, so the innovation of this technology is actually they're using GAN3. GAN3 as the printer. So the GAN3 arm extrusion where they can control the printing from all the inputs that you design, because it all started from your design office. You can use any design software, AutoCAD, AutoRevit, Architects, everything, any software. And the output of this software is input into this machine where we have this software that compute the slicing of the house. Imagine, it's like making Sarawak cake lapis. You know Sarawak cake lapis, there's a lot of layers, right? Small layers. Likewise, when you design a house, then this software will compute all the slicing. So the printer will print upon the slicing. So you understand more when I show you the video. Okay. So the precision of this 3D printing is absolute. That means it can print layer by layer upon every millimeter. So how many slices that can be generated is how many printing line that it will generate to form the completed structure from ground zero to the finishing level of the intended structure. Okay, so we are using cobalt slicing software. And because it's a technology 4.0, I call it now, the concrete is extruded by this beautiful printing head. So every printer, the most expensive part is what? The ink, the printer head. So this is our printer head for the cobalt. So it's a printer that extrude the amount of concrete, or in this case we are using structural mortar to form the structural building of the houses. Okay, so setting up of this machine is actually very simple, and in fact, when we bought this machine, the cobalt engineer from Denmark supposed to fly in, but because of pandemic, so we have to learn virtually. So when we do this, because of time difference, so we work at night to learn this machine. So it took us about almost 2 months to familiarize with mechanical and electrical parts. And of course, being a printer, there's a lot of sensor. But of course, when you maintain it properly, any machine, electronic sensor is always the part that you will have to look after to make sure that the machine works perfectly. So maximum hours of setting up time is actually 8 hours to set up the machine. Now, printer, the most important thing is the ink. So in our construction of this 3D printing, our ink is actually the design mix. So it took us almost 3 months to understand our suitable design mix for our local raw material. Because even though the material is simple, cement or sand, but there's a certain design mix that which you have to develop, because mind you, there's no standard of how to generate this design mix. It's not like a normal concrete where you have 1 to 2, 4 or 1 to 2, 2 or dry mix. For this, the trick of this mortar mix is it has to be hardened quickly, but not too quick and not too slow. Okay, so that we can sustain the thickness and the height of the material. Okay, so once you get the correct design mix, the printing is very precise. If you design the width of the printer or the line, I call it the slicing line, because standard width is about 50 to 65. So the nozzle is extruding all the 50 mm minimum to 65 mm wide of concrete mix continuously. So you can have a very beautiful profile, and even the mix, the concrete, when you extrude, there's a profile. This profile actually is to make the shear interaction. Those of you who are engineers, structural, you know the importance of this shear interaction to have a strong and stable wall when we print. So important aspect of the material is it has to be fast setting design. So enable the concrete to be printed in high high wall thickness, high wall height. So very important, the design mix have to be perfect. So that's why it took us 3 months to study the design mix. So this design mix, we are actually learning together with our local concrete industry. And of course, once it's launched, we are now sitting together with CIDB CRIM, the research, to form a standard for 3D printing in Malaysia, so that everyone will follow the same standard which complies to our local building authority. So this printing can even print all the structures of the houses, especially openings through doors and windows. Okay, so these are all the photos that we took where we actually print the actual building from ground to finish. So you can see a big opening of door, and even the lintel, opening of the window lintel or door lintel can be printed. But of course, when you have lintel, we have to do a formwork to form the lintel. So the lintel actually is also using all the extrusion 3D printing. So in these houses, when you do using 3D printing, there's no formwork involved, only formwork to do the lintel only. Okay, so this is another photo to where I show how you actually prop the opening of the window or door. So there's no limitation of size. So whatever you design in your building, the opening, or even your M&E, is all precisely located. So whatever you input in your design, where's the location of your opening, conduit, power box, services, is all captured. And the printer, once the information data to print, you put in the printer, you print everything precisely. You only need to put the socket box. Or even on your left, you can see M&E. You know the conventional type of when we do M&E, we always grind and cut the wall. So in this process, there's no cutting. You only install the piping on it. This goes the same with plumbing, your water. So 2 days we can print. This is actual site. Actually, the location of this site is in CIDB Sarawak, one of the just nearby the convention center. So 2 days we can print about 1 meter high of wall height. Okay. So the completed 3D view. This is upon completion. So a summary of the printing, there are total 145 layers of materials, where each layer is about 20 mm. So the total print of this house is 46 hours, with a total length printed 9,196 meter, 9 kilometers, with maximum 20 layers per day printing. So the average the mortar strength, structural mortar strength 28 days is about 25 MPa average, and it can go as high as 30. Okay, so what is the benefit of this 3D printing construction? Just what I can summarize is efficient because maximum printing speed is 1 meter per second, and the machine produces less waste. There's no wastage. Whatever you input into the machine is translated into your products. And also 3D printers can finish a home structure in less than few days. Like for instance, this 46 hours of printing. Of course, it's not continuous. Actual 46 hours is actually translated into close to 14 days. Because every day we don't print from morning until night. Because we are actually studying. But if we really want to print continuously, maybe it will take about 3 days to complete everything. Okay, so and also it reduced the labor costs. Why? Because only 2 operators is needed to operate this machine and for construction. Okay, construction of 3D printing may allow faster and more accurate construction of especially complex, as well as lowering all the labor costs and producing less waste. Okay. Okay, so reduce construction waste. Why? Because the wall are printed straight. It's unlike conventional. When you do walls, it's all not straight, wavy. So once wavy, there's a plastering involved, where some part may be thicker, some part may be thinner. But in this case, because it's 3D printing, everything is precise, so it reduces the amount of plastering. In fact, the printing of the wall are so nice, like kek lapis. Some house owner may even like to maintain without plastering. Just plaster the internal inside of the house because of dust. But externally, it looks like a fair finished concrete structure, and there's a design to it. So it can actually also reduce site formwork. In fact, in this construction, we hardly use any formwork. Okay, and because of that, it's a much cleaner and safer site to work with. Okay, and the design is very flexible. In fact, a house, normally when we look at a house, it's normally box, square, 90-degree angle. You can in fact design a house where a curved wall, because printing can be printed curved. So there's, if we want to do it in conventional, of course the formwork have to be curved and of course it's a cost to it. But for this, there's no cost. The cost is only the machine and the time. Okay, so that's why it's a faster construction time, and it's proven when we do the actual construction. So what are the growth in this new market? Actually, this new market is when we do with this 3D printer, it can be to facilitate to print complicated structures or complicated buildings, especially curved structures. And new construction material will be able to develop. In fact, we are now in the midst of collaborating with universities to come out with a much more efficient construction material, especially for the concrete ink, the ink like I call it. So a better design mix, because I always believe concrete is always can be improved. The way we go forward to improve is to reduce the cost of construction and better durability and easy to control the design mix that reflects to our local materials. So, and also 3D printing. Because of the experience of pandemic, we can actually reduce the dependency of foreign workers. Not only foreign workers, but when we have shortages of workers, especially in our construction industry. So this 3D printing is one of the ways that can help to improve our shortages, and in fact, it can actually help to develop more skilled labor to work with this 3D printing. And with that, it can actually help to increase the productivity of the construction as opposed to our conventional labor force. Okay, so I end my slide here with the actual video that we took for the construction of our 3D printing. So the first slide, the first few minutes, you see how we set up the machine and then how the machine print the structures. Okay, cannot. Play. So just bear for a while for them to sort out. This 3D printing we're going to launch by our Minister of Work next Tuesday in CIDB Sarawak. Printer of the 3D gantry. So this is software, the way they extrude concrete. So the success of this 3D printing very much depends on so it took us quite a fair amount of time to learn to perfect the design mix. You can see the uniform of the printer extrude concrete. And whenever there's an opening, they know where to stop, where to turn, and where to go to. Once you press the button, it's automatic print. So once your design are finalized, everything is left to the printer to finish the work. That's how easy it is to print a house. Nothing is impossible. Everything is possible when you do the design properly. And as I mentioned, you can think of any structures, beautiful structures, curved structures, especially curved building, or even a dome can be printed using this 3D printing. And we hope to use this for all the houses, especially for affordable house. Finishing of the building is like many other works. So that's why we purposely unplastered some part of the wall to showcase the beautiful of the concrete printing. It's a 3-bedroom, 2-bathroom, about 850 square feet. Completed in 46 hours and be shut down. So that will help to reduce and also to increase the shortages, to help to address the shortages of houses in Malaysia. Thank you.
Wow, thank you so much, Engineer Ivan. I'm sure the breakthrough of our construction is coming in. I mean, like, it's getting even hotter and hotter. So, okay. I believe like everybody want to ask lots of questions, but please, we siphon that. Even our virtual participant also have lots of questions. Please hold the question. meantime, while we listen to our next presenter, so I also need to siphon my question first. So we will continue to look into the sharing experience from Sarawak Energy. So with this, I would like to welcome Engineer Pramod Kumar to present on your behalf. Please welcome.
Okay, thank you, Eeydzah. Yeah, I think maybe, I think I'll just need to get my slides. So Chang, are you controlling it? Okay. I think it's okay. Finally, I think it is there. Okay, very good afternoon to all. Just a very quick description of the title. PD stands for Project Delivery, and of course, digitalization is one of the efforts that we are embarking on in a very significant way in Sarawak Energy. I will just start off with a little story about Sarawak Energy before going to the main topic of the presentation. I think, okay, so now Sarawak Energy is already 100 years old, and I think we've since then become a fully vertically integrated energy development company and also a power utility company that is also wholly owned by the state of Sarawak. We are regulated by the Ministry of Utility and Telecommunications for provision of electricity, serving a population of 3 million through more than 750,000 account holders. And our vision is to achieve sustainable growth and prosperity for Sarawak by meeting the region's need for reliable and renewable power, powered by a multidisciplinary workforce of 5,400. And today, we are the largest hydropower developer in Malaysia, with an ambition to become a regional powerhouse by advancing hydropower and sharing renewable energy with our neighbors. In this slide, you know, I think what you will note is that over the last 10 years in particular, we have very significantly multiplied our generating capacity and also substantially increased our renewable energy portfolio. In 2010, our generating capacity was only 1,300, and by 2020, we have increased that almost 4 times. With the latest projects that we are embarking on today, we expect that we should by 2030, we will add another 3,000 megawatts. And you will also see that our fuel mix for generation have shifted from originally more than 90% fossil fuel to today 70% renewable. And we are continuing to grow our hydropower portfolio. In fact, my team today is involved in building the Balai hydroelectric project, and that will add about 1,280 megawatts by 2027. But we will also continue to build new gas-fired plants to maintain a diversity in our fuel mix for reasons of ensuring security of supply. It is also important to note that the electricity from our hydro plants are in fact the cheapest amongst all the sources, and for obvious reasons. It costs a lot of money to build a hydro dam, but the fuel is water, and water comes from our rainfall. Unlike in our gas-fired plant, we have to pay a lot of money for the gas that we buy to fuel those power plants. And it is because of that, and it's because of the fact that we are 70% hydro, we are able to, and hydro being the cheapest of the electricity power source, we are able to ensure affordability of our electricity to the people of Sarawak. And in fact, in Sarawak, we have the lowest electricity, the lowest unsubsidized electricity price in the region. Okay. In summary also, we take a holistic view of energy development by balancing energy security, sustainability, and affordability in order to drive the socio-economic transformation of the state. And we will continue to maintain a very high percentage of renewable hydropower and increase alternative energies like solar and biomass in our mix, in our generation mix, in line with the United Nations SDG 7, which is to provide affordable and clean energy for all. We have also plans to integrate large-scale solar into our generation mix by 2030 and biomass by 2040. I'll now talk about our capital project portfolio. We are today, in our portfolio, we have about 40 billion ringgit worth of projects. It is large by any standard because it is an infrastructure development project. So we have 40 billion to be implemented by 2030. About 29 billion of this is generation projects and 11 billion is for transmission projects. And slightly more than half of this is now in the execution phase, and the remaining is in the front-end design and development phase. The large size of this capital investment is quite typical for major infrastructure development projects, and all the more important that in the execution of these projects, we need to embrace technologies and best practices to enable us to implement these projects cost-effectively, timely, and also safely. From past experiences of project execution, we have seen significant cost escalations and also delays, which can have very severe negative impact to the development of the state as well as to the rakyat. In fact, in our internal analysis of some 50 projects executed between 2010 and 2018, we have seen delays averaging about 1.5 years per project, per one of those 50 projects, with the worst case delay of even up to 6 years, and with cost escalation of up to 1 billion ringgit. When you have delays, it's cost, okay? And learning from these, we have instituted a lot of improvements in the process since 2018, with a focus on the front-end design and planning phase in order to increase the likelihood of achieving successful delivery with minimal change. We also engaged an independent third-party expert on project delivery performance to assess how we're doing. And they have determined that for the 40 billion ringgit worth of assessments, work that we're going to do in the next 10 years, if we transition from fourth quartile performance, that which was measured in 2018, to a first quartile, which we are aiming hard to achieve by 2023, we should be able to save in the region of anything between 5 and 10%, which means a savings of between 2 to 4 billion ringgit, which can do a lot for us. But I think, additionally, I think if you look at the last 2 years, for instance, the impact that we have experienced, and is also, I think, illustrated by Mr. Ivan here, we have very, very severe shortages of manpower, very, very severely affecting our project delivery. I think this is just an illustration. In fact, in the last 2 years, and particularly for this year, we have a shortfall of 67% manpower. We require a total of 2,373 workers, but only 792 workers are available on our projects sites, meaning a shortfall of 1,335 people. So construction and commissioning works have been very severely impacted. And additionally, year to date, only 336 workers have arrived against a plan of 1,335. And I think we all know everyone is facing this challenge today. And the delays in our projects are very severely impacting our ability to meet numerous new customer requirements, which ultimately affect the development of the state of Sarawak and also the people in a very significant way. The very heavy reliance on manual workforce, in itself needs to be addressed. We will continue to capitalize on application of advanced technologies to significantly reduce the reliance on manpower in order to mitigate impacts of such as what we're experiencing today. And I think I will share some examples of what we are doing on that front. But I think more importantly also, as I explained earlier, if we are focusing now on the front-end design and planning of our projects. I mean, this is a rather complex-looking process flow for effective project delivery and planning and implementation, but it is also very, very key to doing projects right. The front-end design and planning is key to enable safe and successful delivery of projects. Project objectives complete with a business case have to be defined early in the development phase. Stakeholder engagement is also vital to obtain alignment on the project objectives. And very importantly, there must be a comprehensive risk identification process, and mitigations must be developed early and followed through to completion or closeout. And project teams is very important. Project teams must be involved in the very early phases of front-end design and planning for continuity. I think in a lot of cases what we will see is that somebody does the planning of the project and somebody else go and execute. And very often there are very serious gaps that results in significant changes when you are implementing it, and changes always means delay and cost escalations. Now, because of the complexity involved in doing such projects right all the time, it is inevitable that we need to capitalize on IR 4.0 by applying advanced tools and technologies to facilitate consistency in the development and implementation of our projects. And digitalization is therefore key for effective planning, since the very large amount of data that is being collated and must be delivered to the bidders in a form that is easily understood. This is also important to enable the bidders to plan and develop reliable schedule and cost figures in their tender proposals. I think in this slide, I would like to just share an example of how we have transformed ourselves in the way we do transmission line projects. We have implemented major process changes. For instance, we have transitioned from literally drawing a straight line on a map to using topographical maps and cadastral maps to aid in the determination of optimal line routes that would be technically less challenging and also will help minimize disruptions due to disputes by land claimants. I mean, it's a simple thing like, you know, in a piece of land, when you draw a straight line, you cut through the land, piece of land, and it will be, the way you cut through the piece of land is so disruptive that the land becomes useless. But we could actually alternatively use a cadastral map and follow the boundaries of the land in order to minimize the disruption to the piece of land. So, and also stakeholder engagement with local authorities and project affected communities are very key and has to be done early on in the design phase in order to eliminate showstoppers. LiDAR technology, and you can see something in the corner there, is also now adopted to save significant amount of time to undertake front-end design and planning works. And also, we are applying standardization. We are now introducing standardized towers and foundation designs to enable very significant savings, both in the front-end design phase, in the procurement phase, in the execution phase, resulting also in significant cost and time savings. This is a real-life example of how we have actually realized very good savings, and just by applying all the process changes that we've implemented over the last 3 to 4 years. If you compare a cost per kilometer of a transmission line that was awarded in 2013, it cost 3.2 million per kilometer, converted to money of the day, versus one that was awarded in January this year. It was only 2.6 million per kilometer for a similar 500 kV transmission line project. And this actually translates to a 600,000 savings per kilometer of transmission line. And of course, for a typical 100 kilometer transmission line, which is quite typical in Sarawak, that will be 60 million ringgit savings for just one transmission line. Now, I'll touch on application of disruptive technologies within SCIB now. I'd like to start with construction management. I think in this slide, we are of course, I think there's a nice sharing by Faiz here on BIM. We are also in the process of a major digitalization program for Sarawak Energy, and BIM is one part of that overall digitalization program. BIM, as we all know, is already a relatively major technology which facilitates improvement in front-end design, planning of projects that we are undertaking today. And the image on the left illustrates that the ability to impact cost is highest at the early phase of the project. And it basically means that if you do our planning right, we'll be able to impact costs more significantly if you do that early on in the life of the project. Whereas the cost of design changes increases as we delay the planning phases to a later stage of the project life cycle. And BIM, of course, provides value in facilitating early design to minimize changes during implementation. And as you all know, changes during implementation results in cost and schedule impact. Now, in this slide, this is, of course, we are also looking at the use of prefab. We are collaborating with some of our major contractors for sharing of learning and best practices in construction management. More recently, we have engaged with one of the world's largest manufacturer and implementers of transmission line projects, and who is leading efforts to improve efficiency of the construction of transmission lines or transmission towers, which, as we all may know, is extremely laborious and is conducted in some of the most challenging terrains, especially in Sarawak. As illustrated in this slide, the contractor has formulated the application of prefab and modular construction for tower foundation, which is expected to reduce construction time by an order of about 70%. This is very significant considering that some of our projects have even taken as long as 6 years to complete. Instead of in situ foundation construction, which is very laborious, involving the requirement to manage many safety risks, the foundations are fabricated in a prefab location where quality and safety aspects can be consistently and more effectively managed. These prefab foundations, which weigh only about 3 to 4 tons, can then be easily transported and installed safely onto pre-prepared lean concrete bases, after which earth is backfilled to the required levels for support and strength. The contractor has already utilized these construction techniques successfully in Georgia, USA, and in Papua New Guinea, and SCIB is exploring the use of the same in some of the more challenging project locations. And if successfully applied, we can adopt this technique as a standard for all future projects. I think you can see that the time savings here is very significant. So from 9 days to do one tower foundation to only 2 days, which is a very, very significant cost savings. And the application of digital twins, this is very important as well. In fact, 3D scanning and photogrammetry, this is already utilized today to monitor quality of tower erection works. As you can see in the above, 3D mapping uses both LiDAR and photogrammetry to provide significantly safer and highly efficient assessment of quality of completed tower components. Time savings can be in the factor of more than 10 times, but more importantly, safety risk in undertaking the works is substantially reduced. The overall benefit includes the fact that in the current manual process, the number of towers that can be inspected per week by 3 persons is 10, whereas with the same number of inspectors using drones can complete even up to 60 towers in 1 week. That is a very substantial, especially if we consider also the significantly reduced personnel safety risk exposures. Consequently, also we are looking at very large cost savings. And the third image on the most right shows the use of topographical survey for volumetric analysis of excavation works using LiDAR, which also similarly aids in providing fast and accurate volumetric measurement, increasing the traceability and accuracy of assessment of excavation works. And this is, of course, very important when you want to effect payments to the contractor for the work that they are doing. And with regards to advances in data-driven project management, cloud and real-time collaboration has been introduced in Sarawak Energy many years ago. In fact, I think the benefit of having done this early and also with the integration of ECM and EDM systems, the extensive use of Office 365 suite of applications and multiple other online applications for processing of staff claims, human resource management, and procurement and others. We have also experienced firsthand the benefit of this technology when the MCO was implemented in 2020, arising from the pandemic. The organization was able to very quickly transition into virtual workspaces with very little or no delay, and has performed very effectively with minimal teething problems throughout the pandemic. We are also harnessing the benefits of cloud and real-time collaboration, which extends further into all areas of project management and allowing digitalization of many processes, including project controls, performance management, contracts and procurement, central engineering, health and safety, and environment management in all our project portfolios. Now, on big data and predictive analysis, net energy metering scheme is a billing mechanism that credits direct solar photovoltaic system owners for electricity that they add to the grid. And a combination of this scheme with smart meters collecting big data can allow Sarawak Energy to make predictive analysis for cost-effective management of generation capacities, balancing supply and demand of energies when thousands of PV owners are interconnected. Of course, we have some way to go, and I think to some extent we are challenged by the fact that our electricity is cheap, yeah? And so the uptake of solar is slow in Sarawak, okay? But I understand the government is facilitating this, and more recently, EIU has already launched a guideline to permit net energy metering implementation. I understand the guideline now permits anyone to install solar capacity up to 20 kilowatts, but for capacities above 20 kilowatts, that specific Ministry of Utility and Telecommunication approval is required. Now on Internet of Things, I think shown on this slide is one of the IoT efforts by SCIB for systems and equipments monitoring sensors. I mean, this can be extended to several potential applications like weather, hydrometric stations, street lighting monitoring, smart metering, solar PC array monitoring, and the like. Sensors such as these can be used to boost management efficiency by setting and generating alarms with a call for action. And a use of these in maintenance systems can also help keep track of real-time machine downtime and data on construction sites. And with that, thank you very much. Okay, there is one slide, I think. I missed the, oh yes, okay. This is just to conclude, and I think the conclusion, I won't read the whole thing, but basically the technologies arising from IR 4.0 is playing a significant role in helping us carry out our major capital projects much more efficiently, more cost effectively. Yeah, and on top of that, okay, you have difficulty hearing just now. Sorry, was it too bad? Okay, okay, and on top of that, you know, we will definitely continue to explore the application of a lot of these technologies and also the emerging technologies, and hopefully we can do that in an expeditious manner in order to benefit from the, you know, from the cost and schedule and safety benefits that would be possible through the use of these technologies. Yeah? With that, thank you very much.
Thank you so much, Engineer Pramod, for a very good presentation. Okay, I think we have left another 10 more minutes before 4, but because of this stage is getting hotter, and I mean, I'm sure like everybody want to ask question, and even our virtual participants. So allow, if let's say maybe we might need to extend a bit. We might not be finished by 4, so hopefully we try to target to finish by 4, but before that, let us listen to, is there any question from our virtual participant maybe? Is it okay? Is there any question? All right. All right, so while waiting for our team to, while waiting for our team to pop up the question, let us open the question to the floor. I mean, is there any question from the floor? Okay, please. Maybe you can, just tell your name, where you're from, and the question.
Okay, hi. Assalamualaikum. My name is Siti Asniza Mitiazli. I'm from BCSS Consultancy, Berhad. I'm the BIM manager for the PCSS consultancy. So I have question for our speaker. So for speaker number one, saya dah bekerja dengan template dan proses flow daripada JKR, remarkable, tersusun, teratur. Dan soalan pertama, untuk model integrity checklist, normally at what stage LOD yang best untuk buat model integrity checklist? Is it LOD 300 ataupun LOD 400? Soalan nombor dua, banyak software dekat market. So as a BIM manager, it's hard for me to do some integration because we are a small company. So we need to invest to test everything sebab kita adalah open BIM kan. So is that from your experience, is there any local or local company lah yang boleh integrate all the software into one system, one apps ataupun one environment? I don't know. Untuk speaker number 2, it's very interesting. I know about this technology, but I didn't know that Malaysia, Sarawak dah mula start beli cobot. So my question is, you said that you can export data from Revit, ArchiCAD to cobot. I just want to know what type of file format. Is it IFC, RVT, or what type of the file format? Because I just want to know how high level of information transfer to the cobot. And next question for the speaker number 2. If 2 operators construct one house, is there any possibility that house price can be lower? Yeah, and for speaker number 3, it's very interesting. For SCIB also have a very remarkable process flow for construction management. So I really want to know your point of view. You have a very good process flow. How about, have you considered to adapt or implement or to do asset management and asset tracking? If yes, how you share to user like us, for example, consultants, contractors, and end user like suri rumah, to share asset tracking, asset technologies for SCB? That's my question. Thank you.
Alright, okay. Thank you, Miss. Sorry, not hear your name. Asniza. Okay, Miss Asniza. Okay. So, 2 soalan kepada saya lah. Okay, yang pertama berkenaan dengan model checklist. Bila sebenarnya perlu gunakan lah, betul Alright, okay. Dan soalan kedua berkenaan dengan software. Okay, untuk model checklist tu, actually JKR, for all of your information, when JKR implement BIM project, we will the consultant contractor need to gunakan, use our borang lah. Borang tu model checklist. Dalam model checklist tu kita bagi tahu lah model integrity quality macam nak semak, ada contoh bergambar sekali lah sebenarnya. Okay, sampailah kepada naming convention, semua tu kita bagi tahu lah apa yang kena semak. Jadi so that kontraktor atau perunding dia boleh follow. In the end tu model yang diserahkan kepada JKR atau pelanggan complete. Okay, jadi sebenarnya kalau kita tengok, bila kita cerita berkenaan dengan semakan model, when we talk about the we want to check the model, actually BIM kita bermula daripada fasa reka bentuk konsep lah sebenarnya. Cuma fasa reka bentuk konsep ni, it is the from the planning. So in our definition, it is only LOD 100. Okay, for the prelim LOD 200, detail design LOD 300, for the construction 400, and as-built 500 lah. Okay, so that one we already talk in our garis panduan. And then dalam TOR or need statement, kita dah keluarkan satu level of information, maklumat apa yang kena isi lah. Okay, you need to update in the model. Okay, jadi for the untuk pembangunan development of the model, semakan model boleh dibuat pada peringkat awal lah sebenarnya. So that tak ada yang tersilap. Okay, macam mana cara you buat contoh lah. Let's say you build the column. Okay, kalau you buat daripada awal dah silap, barulah kepada detail nak tembak. Contoh maksudnya sepatutnya dalam JKR kita nakkan kolom tu buat satu tingkat lah. Okay, one floor per one floor. Tapi you start with whole stretch, you build sampai atas. Okay, so bila dah sampai ke pada detail design, takkan you nak buat balik lah. Jadi there's in term of development tu you need to check from the beginning. Okay, for the updating of the information, you need to follow back our jadual lah. Dalam tu jadual beritahu. Contoh kalau create bahan, when you need to put that information from the LOD 200. So masukkan bahan tu masa 200. Kalau pembinaan, warranty, LOD 400. So kita masukkan maklumat tu semasa 400. Jadi cara kita develop model tu perlu dibuat daripada awal dan perlu ikut dari segi pengemaskinian, updating the information inside the model must follow the level of information from the level of development lah. Okay, boleh? Okay, and then the next question about the regarding of the software, what is suitable for software? Okay, some kalau tengok kalau kita tengok JKR dah mention terus. Sebab JKR kami gunakan Autodesk. Okay, we use BIM for BIM. Why use Autodesk? Because in the end, okay, our staff and we want the native file lah, native file. Okay, kita nakkan model tu boleh diguna pakai balik. Rather than you get the IFC. IFC you dah tak boleh buat apa, PDF. Okay, you may get the data, tapi in term of you want to kalau ada buat perubahan dalam building ke apa semua dah tak boleh. That's why in the end, that's why JKR kita stick to the one software. So all our staff, okay, we have 30,000 staff. Okay, takkan nak beli banyak software kan, nak belajar invest banyak. That's why we stick to the one software to use BIM. Okay, that is how JKR. But in the organization, you need to, if you want to select the software, you need to suit back with your organization lah. Contoh lah, kalau saya ni consultant firm untuk CNS, okay, CNS. Okay, what is suitable software lah yang saya boleh gunakan? Contoh saya gunakan Tekla Structure Designers, guna Trimble untuk buat design. Adakah kalau saya transfer this model into BIM model, software apa yang sesuai? Adakah Tekla Structures ataupun Autodesk punya Revit, ataupun apa lagi, guna Bentley contoh atau Glodden. Okay, jadi kita kena tengok bila kita nak select ada software tu, orang our friends, contoh arkitek, consultant, dia boleh tak baca sekali software tu. Okay, so that is how open BIM function lah. Sebab tu kita kena tengok. And then kalau setakat you develop BIM only for the clash analysis, maybe for the CNS no need to buy Revit software, because the TSD we can transfer to the RVT or IFC, and then the architect can get that model to do the clash analysis. So no need that CNS to invest. Okay, that's how. Sebab tu kita kena tengoklah the suitable of the software between our among parties, and then the BIM users ataupun the objective of the BIM, the benefit of the BIMs that kita nak capai lah, the organisation tu nak capai. So kita tengok the whole stretch of the work process. Okay, boleh Alright. Adakah ni lagi satu tadi, local company software? Kemungkinan besar akan ada nanti satu, kemungkinan besar nanti ya. You wait for that software. Ada satu lah, tak silap saya kalau you all ada pergi satu IEM seminar CP development, dia kita punya that is a local company lah yang sedang develop BIM software. Okay, alright, okay, thank you.
Okay. All right. Regarding the first question, all the drawings, whether it's Autodesk or Architect, it can be converted into one file. I can't remember what file it is, but this cobalt software is integrated with all the common common software by engineers or architects. So this software can receive this common file and convert into cobalt slicing data so that the printer can print these structures physically. So there's no issue about what the end user use software to design the first model of the house, because at the end of the day, the completed house, whatever platform they design, can be converted into one common file. I can't remember what file it is, because this file is existed to all the common software users. They can export to this common file, where this cobalt software can able to read this data and convert into the what the printers can read and translate it into the printing process. Okay, and as for question number 2, cost. Okay, at this point in time, we know that the cost saving is on the labor, because labor costs, you know, the productivity is not there, like what our doctor here shared just now. Our conventional labor, the productivity is not up to the cost that we want, the translated cost efficiency. So with this 3D printing, cost efficiency is very much improved, and I can say that we can have a cost saving of labor costs, because why we can save is not only the amount of labor are reduced, but the time saving to complete the structure is very, very much significantly reduced. And also, at this point in time, because this 3D printing is new, the raw material are now in the process of further R&D with a lot of universities to find and optimize the costs, so that we can have a cheaper raw material cost. In fact, the raw material are very much easily available. It's just that we have to design the optimum design mix to suit and to have workable, sustainable structures, so that the house is not only in good quality, but also can be cheap. Cheap in the sense that we don't use so much cement, because most of the cost is in cement. So we can, in fact, our research with some universities to have a substitute, or maybe to replace some percentage of cement, but that doesn't compromise on the structure of the building, the design mix. So that is in the process, in the pipeline, and hopefully we can publish a paper, because as a new player in this 3D printing, we are not only working with CREAM, local university, but also with international bodies, especially the international concrete bodies all over the world, because every part of the world have their own design mix, because different characteristic of the raw materials. So I can say that, of course, the cost will come down. For the time being, is the cost on the saving on the labor, and in the future, I would say maybe give us about 2 years' time, we can come out with a cost saving on the raw material. Thank you.
Sorry, I just wanted to, your name is? Azliza. Aniza. Okay, sorry, Aniza. Sorry, Aniza. I just wanted to clarify, your question is in regards to how do we do asset tracking, is it? Is it correct? Okay. I think, you know, if you talk about asset tracking, there are slightly different level of maturity for the different type of work, different portfolio that we have. If you talk about our generation portfolio, they are already in a very advanced level for some decades, I would say. So and for that matter, all of the documentations that come to us are already in a digitalized form. So when we complete our projects, we actually hand over this entire set of documents to our asset owner. And usually just by going into that digitalized platform, you can have access to every piece of asset that you have. It's just that the generation portfolio, you have documents that are linked to each other in a digitalized form. You can easily trace exactly where this equipment is. You can trace specifications. If you want to buy, for O&M purposes, you want to buy a piece of equipment and so on, you can easily extract the specifications and place the order and so on. So it's actually very easy to do. So that process is already on, because our contractors are required to deliver all of the information to us in a digitalized form. And as I said, that same fully digitalized form which is used in the construction phase is actually ultimately handed over back to the asset owner so that they can use it for their operations and maintenance purposes. I hope that answers it. And of course, we are bringing it to another level, because we are we are in the process of embarking on in fact, we should be awarding a contract sometime very soon to fully digitalize the entire project life cycle that I shared earlier. And that will enable us to have everything in a single platform, but we will also have asset tagging as a very key element in that. So anybody, in the design phase it will be helpful, but in the operations and maintenance phase it will also be very helpful. You can drill down to the smallest component or the smallest spare part of an equipment in that single platform very easily. Yeah. Okay. Okay. Thank you.
All right. Thank you so much. So we do have one question from the virtual session. So this question is to Engineer Ivonson. Any concern in lack of reinforcement bar of 3D printed buildings?
Yeah. Okay. Very good questions. In fact, our model design, we not only because when we create the model, we actually analyze it in finite element. So when we model a house, single story, normally single story is all designed as a compression load bearing. So once it's a load bearing, there's no tension. So in fact, you don't need any reinforcement for single story. But when we come to two-story building, so of course when we design, taking into the fact of some out of plumb line, this more structural technical. So there are some part which is tension. So once concrete is very good in compression, but not good in tension. So once there's a tension, that's where we put a rebar. And normally this rebar is a tension bar, vertical bar. And even though when we design single story where all the walls are under compression, but because of some requirements of robust design, we still have to cater for some movement. So in fact, we didn't capture it in video, but some part, like I can't remember, but I remember that every 1 meter height of wall, and at every interval horizontally, we will put some stiffener bar, where we put a short piece of bar to tie the two walls together. Because if you see in the video, the walls are actually double layer. So that it works as not only to facilitate easy placement of electrical wiring, everything, but also to make the wall stable, where you have some interaction where it works as a unit, like a sandwich wall. So that's why when we design, we take into consideration of all this. Whenever there's some tension, so we'll put some reinforcement. But for single story, small building, normally we don't need. So we just put some stiffener bar at certain interval. And normally this stiffener bar is only, it can be 10 mm diameter of reinforcement. Okay.
All Right, thank you so much. So I think like everyone wanted to ask more questions, but since now it's 4:15, so we have to end our discussion for today. Thanks again if there's a virtual question wanted to ask more question, you may just put it online. So I do hope CIDB will take up the question. And for in-house guests, maybe you guys can ask question after this during the tea break session. So again, before we end up, I would just like to conclude that technology is very much important in order for us to deliver the next revolution in our construction. And having said that, we need to have the governance change, okay? The visionaries from top management need to have the whole, change of management. We are talking about agile management now, so people need to change. The government needs to change in order to execute all the technology in expediting the whole construction process. So with this, again, I would like to thank our panelists for today for such an insightful discussion, sharing experience. So with this, thank you, and Assalamualaikum warahmatullahi wabarakatuh.
All right, once again, please give them a big round of applause, ladies and gentlemen. Majlis mengucapkan terima kasih kepada Dr. Eeydzah binti Aminudin, our